Hi, and welcome to this short content bite in which we discuss the thermodynamics of phase changes. Phase changes are one of the most important concepts that we can explain with thermodynamics. This video deals with the role of enthalpy in phase changes, and you will learn later in the course about the role entropy has in this process. You are already familiar with the common phases of matter, that of solid, liquid and gas. Some systems have more than one solid phase. Water has more than 10 solid phases, and sulfur has 2 common solid phases, monoclinic and orthorhombic. And even between 2 solid phases, there is a measurable thermodynamic phase change. A phase change is the point where 2 phases are in thermal equilibrium with one another, and because of this thermal equilibrium, a phase change is a thermodynamically reversible process. When we talk about reversible processes in thermodynamics, it is a process which is in equilibrium and any change is infinitesimal. Phase changes which occur between the solid and liquid state are called melting, and when occurring from liquid to solid, freezing. When we move between a liquid and a gas, the process is called vaporization, and in reverse, condensation. Finally, phase changes which occur directly between solid and gas at temperatures and pressures below the triple point are called sublimation and in reverse vapor deposition. You already know from experience that if you want to go from a liquid to a gas, you have to put in energy, and conversely, as something cools and then condenses, it releases energy. If I consider the previous statement more formally, I add energy to a system in the form of heat, and the enthalpy of the system increases with it. Usually the temperature of the system will increase. However, sometimes heat is added to the system and the enthalpy of the system increases, but the temperature of the system doesn't change. This occurs when we have a phase transition. Because of this input of heat, which leads to no change of temperature, phase changes were historically called latent heat, and indeed this phraseology is still common in physics. The enthalpy change is a measure of the energy required to break the bonds in the system, with the close formal bonds of a solid being broken to the slightly longer, less organised bonds of a liquid, and then these intermolecular bonds in a liquid being nearly perfectly broken to form a gas. Consequently, as you can see in the data here, the enthalpy of vaporization is always greater than the enthalpy of fusion because the intermolecular bonds have to be completely broken during the process of vaporization. I hope that this introduction to phase change has been useful. We have seen previously that enthalpy and heat are equivalent at constant pressure, and so the enthalpy of a phase change is just the energy provided as heat to break or form the bonds for that process. I hope that this video has been interesting, and as always, if you have any questions, please do not hesitate to ask.